Okay, so it's time to get started. So welcome to the session, the Levchin Prize award ceremony. This is a fun part of the morning where we celebrate contributions to real-world cryptography. So let me just remind you again, kind of read the purpose of the award. So the Levchin Prize basically honors major innovations in cryptography that have had a significant real-world impact. We've been running this award now for quite a while, but first I should say that the award basically started in 2016. It's named after Max Levchin, who is sponsoring the award and has agreed to sponsor it in perpetuity. So we award 2 awards every year, and each award comes with a $10,000 prize. And basically, Max Levchin agreed basically to sponsor this now forever. So this prize will go on forever, which is wonderful. So let's see. So the awardees so far, I kind of listed them here. I guess it's starting to get harder and harder to fit it all on one slide, but I'm very proud of the list that we have so far. These are like, all of these have made very significant contributions to the practice of cryptography in the real world. So it's wonderful to see this list growing, and it's going to grow by more today. Okay, so I guess I should just say one last thing to remind everyone that in fact the award itself, beyond the $10,000 prize, it comes with this wonderful cryptex, which the winners of this year will receive by mail. So you have to solve the puzzle to open the cryptex, and you'll find something inside of the cryptex. Yeah, so this is this beautiful trophy that comes with the award. All right, so now that I think you guys have heard me speak about this now for a couple of years, with that, let's kind of turn to the main event, which is announcing the 2025 Levchin Prize award winners. So yeah, so the award, so 2 awards. Our first award for 2025 goes to, drum roll, yes, yeah, so our first award goes to, to Adi Shamir. I have to say, we actually had trouble with the citation here because Adi made so many contributions to cryptography that we couldn't actually fit it on the slide. And so actually, if you go to the web, on the web, there's a much longer description of Adi's work. But Adi has made foundational contributions to ciphers, cryptanalysis, protocols, public key systems. I kind of picked a really tiny sliver of Adi's contributions, and it's really just mind-boggling that one person can have such an impact on one field. So of course, Adi is the S in RSA, for which he won the Turing Award, but that is dwarfed by everything else that he made, all the other contributions he made to cryptography. So just kind of going through a tiny, tiny sliver of Adi's contributions. So he invented differential cryptanalysis, which in some sense kind of launched the whole field of analyzing ciphers. He had this amazing contributions on what's now called Shamir secret sharing, how to share a secret. Again, a beautiful contribution to the field. Of course, invented the Fiat Shamir transformation. So this is this how to prove yourself paper, which many of our works would not be possible without the Fiat Shamir transformation. And along the way, he also proved this fundamental result in complexity on interactive proofs, which says that IP is equal to P space. And again, this is just a tiny sliver of all the contributions that he made to the field. So it's really remarkable that one person can have such an impact on the practice of cryptography. So really, it's a wonderful pleasure to award this award to Adi Shamir. So Adi, please come up to the stage and let's all congratulate Adi. And before I hand it over to Adi to say a few words, I did want to make one comment. So as I said, the award comes with a $10,000 prize, but Adi actually decided to donate this his own prize for student support at RWC. And in fact, some of the support that goes to all of you, to some of the students who are here, are actually thanks to Adi's contribution. So thank you so much for doing that too. Okay, so with that, Adi, I'll hand it over to you for some words of advice. Oh, what's doing it?
So I was asked to talk for about 5 minutes, and I thought that I'll give you some advice because I see many young faces here, many people at the beginning of their research career, And I've been in this research area for a very long time. So I'll try to distill 3 things from my experience so far. So my first piece of advice to everyone is to read. You should read every paper, both within your field and outside of your exact research area. At the beginning, in the late 70s and the early 80s, the field was so small that I made sure that I read every single paper that was published in cryptography. At some point, it became quite difficult, as you can imagine. And then I made a vow to read every abstract of every paper which appeared in cryptography. And this also worked for a while. And I must admit that in the last 10 or 15 years, the most I can do is to read every title of every paper that appears in cryptography. But please try to read as much as you can. The second piece of advice is what kind of problems you should try to work on. So here is how I suggest you divide your time. Spend about 25% of your time working on the hardest and most interesting open problems in your field. Identify them and spend some time. These are the moonshots. It's very likely that you will not be able to solve any of them, but if you do, this will base your career upon. You'll become world famous for solving one of those problems. So please spend at least 25% of your time on the moonshots. Then spend about 50% of your time on regular kinds of problems, those which have a good chance of being solved. Try to find interesting problems, those that can be published at good conferences. This will be the bread and butter of your CV, and you're likely to have many good, interesting papers based on this. And the last 25% of the time, just play. Think about all kinds of amusements, how to twist things in a very unusual way. I know, for example, that the way I got my idea about secret sharing was because I read a kind of puzzle about a bank which wanted to safeguard the safe, and it wanted to give keys to the various executives of the bank so that any 3 of them will be able to unlock the safe. And the question was, prove a lower bound on how many keys you have to give each one of those executives. And as soon as I read this, I said, we are living in a new world. We now have cryptography, we have tools. Why don't we try to solve the mathematical version of this problem, not with actual keys for the safe? This led me to the paper about secret sharing. And the third piece of advice I can give you is to diversify. You saw that I haven't stayed in one area for the whole career. And I can tell you that it will be extremely useful if once every, I don't know, 5 years, 10 years you choose, you'll switch to a new topic which becomes trendy, which raises new kinds of problems, and it will do wonders to your career. I've started in public key cryptography and then moved to protocols, moved to zero knowledge, moved to complexity, moved to cryptanalysis of symmetric ciphers, moved to side channel attacks. And I can tell you that many of my recent research papers are related to combinations of ideas from different areas. So please try to keep those 3 pieces of advice and you'll launch a great career. Thank you. And finally, I want, of course, to thank the Max Levchin and the selection committee for selecting me. Thanks. Great. I'll stay here.
Okay, perfect. That was excellent. And as I said, we have 2 awards every year. So now we move on to our second Levchin Prize winners. And the second Levchin Prize winners for 2025 is actually the Keto NFS project. So Pierrick Gaudry, Emmanuel Thomé, and Paul Zimmermann, please come on stage. This award is for developing Keto NFS and for continued factoring and discrete log records. So before I hand it over to you, let me just say a few words about Keto NFS. So Keto NFS is actually a complete open source implementation of the number field sieve for factoring and discrete log. The latest records in factoring and discrete log were achieved using Keto NFS. I wrote some of the numbers here. You can see the computation costs. These are massive projects that were done using the software system. And so for this contribution, the team is winning the 2025 Levchin Prize. And so with that, I'll hand it over to the three of you to say a few words. So congratulations.
Thank you. Thank you, Dan.
The floor is yours.
Thank you. I'm very honored that we're receiving this award this year. Thanks for choosing us. The Levchin Prize means a lot to us for a software project such as Keto NFS. So I'm going to say a few words about Keto NFS and leave whatever negative number of minutes will be remaining for my two colleagues to comment on a few aspects. So Keto NFS started in 2007 as mostly some kind of a team building project. And so it's gone a long way since then. I think that along the way, some people contributed, including PhD students. I think it's fair that I mention Alex Krupa, who was among the ones with the most substantial contributions to Keto NFS. And Keto NFS now is something like 250,000 lines of C and C++ code, which by academic standards is kind of large. So we didn't start with the goal of setting records, but we did have some backgrounds in running computations and also the mathematics behind the number field sieve, which made us kind of well equipped to deal with this task. And so Keto NFS, we started with the goal of making this complete implementation of the number field sieve. And at the time, there was no such complete thing. So we decided that it was going to be LGPL, meaning that we were going to reinvent the wheel for many things. So it kind of slowed us down at some point, but it's also interesting that we did that. And then after a while, of course, we got interested in ramping up and tackling larger and larger computations. And the numbers that Dan showed kind of proved that we went a long way in this direction. So in the beginning, it was only factoring, and discrete log came afterwards. And the funny thing about the number field sieve, I mean, it's a complicated algorithm, and transferring from a factoring only software to something that deals with discrete logs brings kind of a lot of complications. So it was funny. I mean, there are many points in time where I thought I knew the number field sieve and realized that there was some glitch that I wasn't completely okay with. But so the latest records that we obtained 5 years ago, I mean, that's 250 digits for factoring and 240 decimal digits for discrete logs. And the natural question is whether we'll be doing RSA 1024 someday. I mean, it's on paper, it's like around the corner. It's like pretty clear that it's doable, but it's like 50% a question of having big pockets and 50% a question of optimizing the implementation and making it able to deal with such challenges. So if you do have big pockets, you will still have the implementation part to do. And if I had an infinite amount of time, I would still need some resources because they are not in my basement. Okay, so that's about it for what I wanted to say. So maybe I hand over the mic to my two colleagues. I don't know if I would factor 1024 first, but oh, I'm sorry. So Dan is asking whether my guess is whether me or a quantum algorithm would factor 1024 first. So I don't know about me, but I don't give a penny on a quantum computer factoring 1024 anytime soon. So it leaves us at least 20 years, if not more, to factor 1024. That's my guess.
Okay, so I will say only a few things. So, like Adi, I will say some advices for young people. So I'm very happy to have many young people here. So my motto will be code, code, code. So in my career, I have implemented many algorithms. When you try to implement a real algorithm, you find bugs, of course. You find improvements, so it's very nice. And last thing I wanted to say, so I'm very happy to be here, but when on February 13, I entered the lab, I saw Emmanuel, I said hello to him like every day. And he told me, did you read your email? Oh, okay, I saw some email, but not. And in fact, I had deleted the mail from Dana because I thought it was a spam. Okay. So please read your mail.
Okay, just a few words. So thanks a lot for to the committee for this prize. Actually, I'm very happy that such a long-term project gets recognized. This is not always easy to have a long-term project in the academia because you have to get grants and blah 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 and get results. So it's a very good to have this kind of recognition for such a long-term project. And maybe something I would like to mention also is that I really like the incentive for cryptanalysis, the incentive given by the challenges like the RSA challenge or the Certicom challenge in the old days. Nowadays, there are challenges for lattices. Maybe there are not yet challenges for isogenies, but challenges for cryptanalysis give a good incentive to write software like CADO-NFS that really helps getting a hand on the real difficulty of the problems. So yeah, that's what I wanted to say, and thanks again.
Congrats to the winners of this year. So with that, let's see, this concludes the first part of the ceremony. I did want to say that we are always seeking nominations from the community, for the prizes for next year. So if you go to rwc.icr.org, there's a Levchin tab, and there's a form in which you can nominate your colleagues. So please nominate. It really helps us in choosing the winners. We take your nominations very seriously. So please go ahead and do that. It will help us for the following year.